All right, welcome back. We're going to go ahead and knock out the evens for this section, 18 through 48. Again, 30 problems or so. That just takes a long time to go through these. So for the sake of time, I'm going to go through the evens. If you would like to have if you have any questions on the odds and you want to take a look at something, just email me or take a look at the solutions manual because it'll have the steps on answering those as well. The odds from each section should be fairly similar to the evens. There shouldn't be a big difference. It's not like the evens should be one type of problem. The odds should be a different type. They should be all pretty similar. But again, if you have a question, let me know. I'm happy to work it out, send you a picture of it, or do a Zoom call with you real quick. But just a quick refresher, I want to throw a couple things on the screen. We talked about this idea of completing the square. Again, the process of completing the square basically takes you from a standard form quadratic to a vertex form quadratic. There's two main ways that you can complete the square. For me personally, I really like this formula. It's important to kind of understand and know how to algebraically complete the square. But being able to plug things into a formula, it's just a lot more convenient. It's a lot quicker. I'm going to do at least a couple of examples of completing the square the other way. But when I start to see fractions or decimals, I might just go to this method right here, just because, again, it saves time. I don't want these videos to be like 2 hours long. I'll show you both methods, but I'll probably lean heavier on this idea of just doing D, E, plugging them into the equation, and you're done. It's nice. I did write this out, but I didn't put it up in the first part of the video. So these are steps to completing the square. So again, some people like steps. I'm going to try to get all of this on here. Let's see if I can do this. I'll just move the paper up here in a second. So this is just kind of the steps to completing the square. If you like steps, you're more than welcome to take a screenshot of this or copy this down. I'm a huge proponent of not just copying down my notes, because again, these are kind of the Algebra 2 way of explaining completing the square. I would highly recommend, as we're going through the video in that first part and we're going through each step, for you writing yourself your own steps instead of copying mine. Because again, these are my steps. These are the Algebra 2 way of doing them. You could summarize these steps, maybe even combine a couple of steps that make a lot more sense to you. So if you want these, you're more than welcome to. But again, I would highly recommend, as you're going through that process in the first video, of completing the square, just kind of jot yourself down some notes on each, the steps if you like that. So just to go through this idea real quick, when you're completing the square, typically you're starting off with a standard form quadratic. Before you complete the square, A has to be equal to 1, and it has to be positive. So if it's not, you've got to make it equal to 1 and make it positive. So we saw an example of that. Let me go back and look real quick with this example here. When we did this towards the end of that last video, we kind of went through, we moved C over to the other side, we took the GCF out, so you'll notice that your A value is a 1x squared right there. So really important, otherwise this process isn't going to work for you. Make sure A is equal to 1. So here we divided every term by A. That's what that means. So now A is 1x squared. When you divide other terms by A, it might be a decimal, it might be an integer, it doesn't really matter, but you have to divide everything by A. Or take a GCF out like we did in that last example I was just pointing to. For step 2, make sure you move that constant term over to the right-hand side. So it's going to be a number. So again, for example, take a look at this one. We had positive 1 on the right-hand side, so we went ahead and moved it to the other side by subtracting 1 from both sides. So all that was left was our A and B term. The C term was on the other side of the equation. Then we'll complete the square. Remember, the process of completing the square is taking that B term, whatever that B term is, dividing it by 2, and then squaring it. Okay? Steps 4 and 5. So you're going to add the square to the left and the right side of the equation. Remember, you have to keep it balanced, so make sure you're adding them to both sides of the equation. And then you're going to factor. So use slide divide bottoms up, use box and cross, however you want to use it, but factor the left side. So here we factored it. X plus p squared equals q. So once you do this on the right-hand side, all you have are numbers. So this is like, I don't know, 15. And after you do the math, this will be like 5. So this will be 20 here. So again, lots of algebra here, right? B divided by A divided by 2 squared. We're going to see this method again over and over, so you'll be able to kind of follow along. And then move Q back over to the other side of the equation. So again, now it's in vertex form. X plus p squared minus q equals 0. All right. So we'll start off with 18. So for number 18, we've got 9 equals x squared plus 2x plus 1. So right off the bat, it looks like, 9 is already on the left-hand side, and you have a constant on the right-hand side. So I think these examples, these 6 examples here, are closely connected to example 1. And if you think back to example 1, that's the one where they're telling you it's a very specific example where both the left side and the right side are perfect squares. And in this case, they are. Remember, when I say a perfect square, I just mean if you take something and you multiply it by itself, you're going to get that something squared. Okay? But it's got to be the same exact thing. So for example, 3 times itself is 9, right? So that's a perfect square. If I factor x squared plus 2x plus 1, again, this is the process I'm doing, and I'll kind of work through this step by step with this example to show you, but just think we're going back to last week. So x squared plus 2x plus 1, there is no GCF. I'll go ahead and do my cross. A times C is 1, B is 2. I need 2 numbers that multiply to 1, and those same 2 numbers have to add to 2. So that's going to be 1 and 1. I'll always go back and divide by A. In this case, A is 1. So again, if I divide by 1, it doesn't change anything. 1 divided by 1 is still 1. But notice that both of my numbers are exactly the same. They're both positive 1. So when I factor x squared plus 2x plus 1, that gives me x plus 1 times x plus 1. But like we emphasized in that first example, these 2 things that I'm multiplying together are exactly the same. So I can rewrite this as 9 equals x plus 1 squared. Again, I can think about 9 as 3 times 3, or 3 squared. Here's that kind of unique example where the left side and the right side are perfect squares. So I could take the square root of both sides. The square root of 9, or the square root of 3 squared, is just 3. The square root of x plus 1 squared, what essentially you're doing is the square root and the square are canceling each other out. I'm left with just 3. Same thing here. The square root and the square are canceling each other out. I'm left with just x plus 1. But that reminder that I told you back in the last video, the square root of 3 is actually positive or negative 3. And I know that because 3 times 3 is 9, negative 3 times negative 3 is 9. So I have to take the positive and the negative version of those things. So here's the part where I'm going to take x plus 1, and I'm going to set it equal to positive 3. I'll also take x plus 1 and set it equal to negative 3. Those are my 2 values. So here I'll subtract 1 from both sides. Here I'll subtract 1 from both sides. And I get my 2 answers, x equals 2 or x equals negative 4. So again, this is just a very specific type of quadratic. There are definitely other ways to do this. Let's just check it real quick. If I were to subtract 9 from both sides, let's just see what happens. Subtract 9 and make this thing equal to 0. And then I jump into my slide divide bottoms up. A times C is -8. B is 2. Do I have two numbers that multiply to -8 and add to 2? Yes. So at this step, I would just take the opposite of those two numbers. So if that's a +4, the answer is -4. If that's a -2, the answer is +2. But remember, you can always check this to see if that's going to be a little bit quicker, but not all these quadratics are always going to work out to where you'll come up with two numbers. And I'm sure we'll see an example of that here in a little bit. So just be prepared with all this stuff in your toolbox. So you could do this if you can, but if you can't do that, you can do, square root of both sides. There's lots of options that you have available to you. So 20, 50 equals 2x squared plus 16x plus 32. I'm assuming this is the same thing. Again, this is linked to example 1. So I'm assuming they want us to create a perfect square on the right, take the square root of both sides. We'll see what happens here in just a minute. Looking at this, I'm noticing that all of these numbers are even, right? 52, 16, 32. So I think I can take this and divide that entire equation by 2. So 50 divided by 2 is 25. 2 divided by 2 is 1. 16 divided by 2 is 8. 32 divided by 2 is 16. And that took care of, remember that requirement, rule number 1, where that leading coefficient has to be a +1. It can't be negative, it can't be something else, otherwise we're not going to be able to do the perfect square, or to complete the square. So at this step, the left side, that is already a perfect square, because remember, a perfect square is just when you take a number and multiply it by itself. So 5 times 5 is 25. So that's a perfect square. What about the right? A times C goes at the top, B goes down below. Two numbers that multiply to 16 but add to 8 are going to be 4 and 4. Again, no big surprise. Those two numbers are exactly the same. So what I have here is 25 equals x plus 4 times x plus 4. But since these two things are exactly the same, I can rewrite this as x plus 4 squared. So here's that idea with this unique type of problem where the left side is a perfect square and the right side is a perfect square. I can take the square root of both sides. The square root of 25 is positive or -5. The square root of x plus 4 squared, remember what's happening is you're taking that square root and that square and they're kind of canceling each other out. So all you're left with is just that x plus 4. That's it. So to solve, I'm going to take x plus 4 and set it equal to +5. I'll also take x plus 4 and set it equal to -5. Do the math. And then those are my two answers. Let's see if this one would have worked out. So if I subtract 25, okay, so I don't think this one will. Let's take a look. So if I set this up, 25 equals x squared plus 8x plus 16. Subtract 25 from both sides. I get 0 equals x squared plus 8x minus, oh, this one does too, minus 9. So two numbers that multiply to -9 but add to 8 are 9 and -1. So again, you didn't necessarily have to go through this process. You could have just factored it and moved that over to the right-hand side. But again, not all quadratics will let you do that, so be careful. 22. 7 is not a perfect square. So what I think I'm going to go ahead and do is move 7 over to the other side, because if we are able to factor this and change this to like x plus 2 or something like that, x plus 2 times x plus 2, I think is what it's going to be. You're not going to be able to take the square root of 7 and the square root of that. So let's see if we can make this equal to 0. Because again, the square root of 7 is a decimal. It's not a nice number. 7 is not a perfect square. So we'll have 0 equals x squared plus 4x. What is that? Minus 3. Let's see if we can factor this. A times c. And b goes at the bottom. Two numbers that multiply to -3 but add to 4. What is that going to be? If they multiply to -3, I could use... I don't think I'm going to be able to come up with anything. The only thing I can use are 3 and 1. -3 times 1 is -3, but -3 plus 1 is -2. Or if I switch those, +3 and -1, they still multiply to -3, but now they add to 2. So I'm not going to be able to solve it using that method there. So I think what I'm going to do is I'm going to backtrack. I'm going to rewrite my original problem down. So ignore those steps of checking. And then I'm just going to factor the right-hand side. So on the right, so don't worry about the 7 right now. A times c is 4. B is 4. Two numbers that multiply to 4 and add to 4 are 2 and 2. Again, my a value is 1, so dividing both of those by 1 doesn't change anything. So right now what I have is this x plus 2 squared. Don't forget, I'm kind of skipping this step where I have this. 7 equals x plus 2 times x plus 2. Okay, that's a +2, +2. That's a +2, so +2. But since those two things are the same, I can write that as x plus 2 squared. I think this might be an example of like an I value. Let me see. Well, we'll go ahead and kind of complete this one out. It's a little bit different than the example that they showed back at the beginning, but I'll show you what the difference is. So on the left, if I take the square root of 7, if you type that in the calculator, it's going to be like 2 point something, basically a decimal that goes on forever. So I don't want to write a decimal and then round it, because technically that's not the same thing. So I'm going to leave that as square root 7. If I change that to 2.4567 and then rounded it, it's not the exact same thing. So I'm going to leave it as square root 7. And then on the right, again, the square root and the square undo each other. So I'm left with x plus 2. Okay. Just keep in mind, when I square root that number, it's always the positive and negative version. So just like before, I'm going to take x plus 2 and set it equal to positive root 7. And then I'll take x plus 2 and set it equal to negative root 7. So don't get sidetracked. Don't let it confuse you that we have root 7. Square root of 7 is just a number. If I have my phone here, I would tell you what it is. But again, it's like 2 point something. So if I solve this, I'll subtract 2 from both sides. And I get x equals the square root of 7 minus 2. And x equals negative root 7 minus 2. They look a little bit funny, but again, we're in Algebra 2. Things start looking a little bit funny. Not all of our answers are perfect integers, nice even numbers like that. We're going to get fractions. We're going to get decimals. We're going to get answers that look a little funny like this. But if you type this in a calculator, I don't know what that's going to be. 2 point something minus 2. So it's going to be just like point something. I'm not sure what the number is. Same thing with over here, negative 2 point something minus 2. So this is like negative 4 point something. So again, it's just a number, it's a decimal, but we're leaving it as root 7 and negative root 7 just because those are exact. Okay. 24. Rewrite the equations in the form, so basically complete the square. So for 24, it's 0 equals x squared minus 18x plus 64. So let's go ahead and complete the square here and kind of use the long, kind of the drawn out algebraic method. And then maybe we'll use that, that formula for the two values here on the next one. So in this case, if I move this constant term over to the left-hand side, I'm going to subtract 64 from both sides. And then I'm going to find what b divided by 2 squared is. So in this case, b is negative 18. So it's going to be negative 18 divided by 2 squared. Negative 18 divided by 2 is negative 9. So negative 9 squared is 81. So 81 is going to be that magic number that I need to add to both sides of the equation. So I'm going to put an 81 on the left-hand side, and I'm going to put an 81 on the right-hand side. Make sure you balance it out. You've got to do 81 on the left and the right-hand side. So this magic number on the left and on the right is going to help me complete the square. Remember, a shortcut is just take the square root of that number to figure out what you're doing here. So the square root of 81 is going to be what, 9? So it's going to be x minus 9 squared. If you don't know that, if that doesn't make sense just by taking the square root of that, remember, you can just do your box and cross method. A times C, that's 81. B is negative 18. Two numbers that multiply to 81 but add to negative 18 are negative 9 and negative 9. We're completing the square, so these two numbers should be the exact same number. If I go back and divide by A is 1, so it doesn't change anything. So there's my negative 9, there's my negative 9. So that's going to be the same thing as x minus 9 times x minus 9, or x minus 9 squared. Same exact thing. Then on the left, 81 minus 64, that's 17. So if they want us to put this in vertex form, I'm going to go ahead and subtract 17 from both sides, and I get 0 equals x minus 9 squared minus 17. I just looked at the instructions. X minus p squared equals q. So it looks like they want us to keep it in that form, which would actually be this right here. It's the same exact thing. These two things are perfectly equal to each other. We're just really used to moving that constant over to the right-hand side and keeping that equal to 0, but this is actually what they're looking for. So I got to do a better job at reading the instructions. So right there is where we could have stopped. 26. X squared plus 3x minus 27/4 equals 0. Again, let's do another one kind of like we did with 24, just to emphasize this idea of completing the square. A is already 1, so we're good to go. I'm going to go ahead and move that constant to the other side of the equation. So I will add 27/4 to both sides. And I have x squared plus 3x equals 27/4. I'll calculate my b divided by 2 squared. So b is 3. 3 divided by 2, that's not a nice number, so I'm going to keep it as 3 divided by 2. You could change that to a decimal if you want to, but that's going to be the same thing as squaring the top, which is 9, and squaring the bottom, which is 4. So it's going to be x squared plus 3x plus 9/4 equals 27/4 plus 9/4. Again, at this level in Algebra 2, don't be afraid of fractions, don't be afraid of decimals, don't be afraid of square roots, that's okay. So on the right, we'll go ahead and clean that up. Since they have common denominators, we can add these two numbers. That's 36/4, which I think, can that simplify? That's a 9. So that ends up working out nicely. And then on the left, again, you could set yourself up with a cross, but if you do AC at the top and then B down below, that's a little more difficult to kind of come up with those numbers when they're fractions or decimals or something nasty like that. So remember that shortcut. What you're essentially doing is taking the square root of that C term. So again, the square root of 9 is 3. The square root of 4 is 2. And I think in this case, they're both going to be positive. So that's where they want us to stop. The instructions say they want it to be equal to that constant on the other side. So that is my last stop right there. Again, try not to be freaked out when you start seeing fractions and decimals, because it's just kind of part of the process at this level in math. So 28, again, here's another one. 0 equals x squared minus 3/2 x minus 70 over 8. So what I'm going to do here is go ahead and add that constant to both sides. So on the left, I have 70 over 8 equals x squared minus 3/2 x. So I will find out what b divided by 2 squared is. So b is negative 3/2. And when I divide that by 2, I will square it. So again, type in a calculator if you're not comfortable with doing this. Negative 3/2 divided by 2, that's the same thing as negative 3/4. And when I square that, that's going to be negative 3 squared is 9, 4 squared is 16. So that magic number is going to be 9/16. So I'm going to add 9/16 to the left side, add 9/16 to the right side, and I'm ready to go. These don't have common denominators. So again, I don't want to get too far into adding and subtracting fractions and make this video even longer. So if you forgot how to add and subtract fractions, make sure you go and watch a video on that. But if I add these together, I need to have a common denominator. So that's going to be 9/16 plus 140/16. That's going to be 149/16 equals. Again, if you set yourself up with the cross like we did here, that's going to be pretty difficult. Coming up with two numbers that multiply to 9/16 and add to negative 3/2. That's just going to make your life a lot harder. So remember, just take this constant term and take the square root of 9/16. So the square root of 9 is going to be 3. The square root of 16 is going to be 4. So it's going to be an x and a 3/4. Okay, just take the square root of the top, take the square root of the bottom. That'll set you up and give you that number you're looking for. But now we have to think, is this going to be positive 3/4 or negative 3/4? I think it's going to be negative because that b value is negative. Can we simplify that? I don't think so. 149/16 can't be simplified. So that would be our final answer. Look at 30, solve the following quadratic equations by completing the square. So I think this is the one where we will kind of use that formula, and for people that want to see that, they'll be able to see some examples of that here. So if you forgot what that formula was, let's see if I can get this on here. I'll go ahead and write it up here. D is going to be, so I'm going to leave this here for a second so people can write that down if you don't already have it. So pause the video, write this down, make sure you have that. If you're going from standard form to vertex form, whatever your A value is going to be on the outside, and then parentheses x plus whatever your D value is, that's how you calculate it. We're going to do that here in a second. And then n parentheses squared plus whatever your E value is. So just plug that in and calculate it as well. All right. So in this case, to calculate our D value, again, that is B divided by 2A. So B divided by 2A. In this example we have, it looks like A is 1, B is 8, C is 60. So for D, it's going to be 8 divided by 2 times 1. 2 times 1 is 2. 8 divided by 2 is 4. So for that D value, to plug everything into that formula, we're going to replace D with 4. And then for E, remember that formula is C minus B squared divided by 4A. So it's going to be, instead of C, it's going to be 60 minus B squared, so 8 squared. 4 times A is 1. And now you just plug it into a calculator, do the math, whatever you want to do. 8 squared is 64. 4 times 1 is 4. So technically this is 64 divided by 4, which I think is going to be 16. So 60 minus 16, that's going to be 44. All right. So again, using this formula method, it is a lot quicker. It's a lot more precise. You're just plugging in information and calculating it. So I'll put this back up there. And now we're just going to take this standard form equation that they gave us, and we're going to plug it into this vertex form. So A, looks like A is 1. So again, you could put 1. A lot of people don't. They just leave it blank. Parentheses, x plus D. We found out that D was 4. So x plus 4 squared. And then on the outside, plus E. We found out E was 44. So plus 44. So for me personally, I would not write 1. I would just leave it blank as x plus 4 squared plus 44 equals 0. All right. So I'll go ahead and put this kind of notes thing away. So again, make sure you have a snapshot of that. Pause the video, get that information copied down so you know where to put everything and how to calculate it. And then let's knock the rest of these out. So 32. 4x squared plus 16x minus 65 equals 0. One thing you'll remember back from the beginning of this video, I gave you these steps, right, to complete the square. One of the important thing is if you want to complete the square, you'll have to make sure that this equation has an A value of a positive 1. So if you're looking at 32 and you want A to have, and you want to do complete the square, make sure you go through here and you divide everything by 4. If you do that, this is going to be a 4, but I think that's going to be a decimal. So if you're completing the square like we have been so far, make sure that A value is a positive 1. All right, so with 32, I just looked over at the instructions and it says they actually want us to solve these problems. So with 30, we would have done the exact same steps, but at this step, instead of just putting it in vertex form, you would solve. We're not gonna do this one though, because again, this is an example where it has an imaginary number and I don't really want you guys getting into that. So we will solve 32. So for number 32, go ahead and make sure if we're trying to complete the square, we want our A value to be 1. So I'm basically going to take this and divide the entire equation by 4. So it's going to be x squared, because 4 divided by 4 is 1. 16 divided by 4 is 4. This is the part that kind of gets a little bit nasty. Negative 65 divided by 4 can't be simplified. It's just negative 65 fourths. And then 0 divided by 4 is still 0. If you want to stick with this, you can. If you're comfortable with fractions, you can also rewrite this as x squared plus 4x minus, let's see what 65 divided by 4 is, 16.25. So either way, it's completely up to you. If you're more comfortable with decimals, go ahead and switch it over to a decimal and then go through the steps. Either way, you're going to get the exact same answer. It doesn't matter. I guess I'm assuming people will be more comfortable with decimals. So I think I'm going to go ahead and move forward with decimals. But fractions, it'll be the exact same steps. So in this case, I'm going to add 16.25 to both sides. So I will prep this problem and get it ready to complete the square. On the left, my b value is 4. So I will go ahead and take 4, divide that by 2, and then square it. So 4 divided by 2 is 2. 2 squared is 4. So to complete this square, it's going to be x squared plus 4x plus that magic number of 4. And on the right, we're also going to add that same magic number. Because again, you can't make this equation unbalanced. If you add 4 to the left, you have to add 4 to the right. So if I factor this, a times c goes up top, b goes down below. So this is exactly what we did last week. Two numbers that multiply to 4 but add to 4 are going to be 2 and 2. Notice they're the exact same number, positive 2 and positive 2. So instead of listing this as x plus 2 times x plus 2, I can write this a little bit cleaner as x plus 2 squared. And then on the right, 16.25 plus 4 is 20.25. This is kind of where we stopped with 30. I just moved this over to the left-hand side and boxed it off. But again, I went back and read directions. It says solve. So we actually need to solve this problem. So here's the point where we're going to go ahead and take the square root of both sides. So if I square root the left and square root the right, remember the square root and the number undo each other. So I'm left with just x plus 2. Take my calculator. The square root of 20.25 is 4.5. So I'm going to go ahead and write 4.5 on the right. But again, don't forget, whenever you square root a number, you're always going to talk about the positive and negative versions of that number. And again, like we've said, 4.5 times 4.5 is 20.25, and negative 4.5 times negative 4.5 is also 20.25. That's why you have to include both positive and negative. So here's the part where we're going to take x plus 2 and set it equal to positive 4.5, and I'll also take x plus 2 and set it equal to negative 4.5. Go ahead and do the math, subtract 2 from both sides. I get x equals 2.5 as one of my answers. Subtract 2 from both sides, I get x equals negative 6.5 as one of my answers. All right, so 32 is done. 34. Three x squared minus 6x plus 13 equals 0. So here's the part. I'll go ahead and prep this and get this all ready for completing the square. In this case, that a value is a positive 3, so I'm going to have to divide everything by positive 3. 3 divided by 3 is 1. Negative 6 divided by 3 is negative 2. 13 divided by 3 is just a decimal, so you can keep it as 13/3, but I'll write it as a decimal over here. 0 divided by 3 is 0. Or I could write this as a decimal. 13 divided by 3 should be 4.3 repeating. See, here's the part where, you know, it's going to be something like this. 4.3 repeating. I don't really want to round that as leave it as 4.3 because then all the information below it kind of gets off little bit by little bit. So I think this is going to be an example where I stay with the fraction. I don't really like rounding numbers when I don't have to. So I'll stick with this fraction. I'm going to go ahead and subtract 13/3 from both sides. So I have x squared minus 2x equals 13/3. I'm going to come up with that magic number that's going to let me complete the square. So it's going to be b divided by 2 squared. Negative 2 divided by 2 is negative 1. Negative 1 squared is 1. So that magic number that I came up with is a positive 1, but if I add it to the left, I have to add it to the right. And now I can factor. Remember, coming up with the X method, slide divide bottoms up, plugging in A times C at the top, B down below, coming up with two numbers that multiply to 1 but add to negative 2. That's great. But you can take that shortcut where you just take that C value and just take the square root of it. The square root of 1 is 1, so I know it's going to be X and a 1 like that. I just have to come up with the sign. Well, I know that if I'm adding two numbers and I want them to multiply to a positive number but add to a negative, that number has to be negative. So if you're comfortable with going that kind of shortcut route, that's great. But if not, just draw yourself an X. It doesn't take that much more time. 13 thirds plus 1, that's going to be 16 thirds. And now I'm going to go ahead and do what I did with that last example. Take the square root of both sides. The square root of x minus 1 squared. The square root and the square kind of eliminate each other, so all I'm left with is x minus 1. I know when I take the square root of a number, it's going to be the positive and negative version of it. So I can think about this, instead of thinking about this as the square root of 16 thirds, I can think about that as the square root of 16 over the square root of 3. That's the same exact thing. So the square root of 16 is 4. The square root of 3, that's just a decimal, so I'm going to leave that as root 3. And then I'm going to go ahead and simplify this. So it's going to be x minus 1 equals 4 over root 3. And it'll be x minus 1 equals negative 4 over root 3. So I'll add 1 to both sides. And then over here, I'll also add 1 to both sides. And then this is the point where I would just type this into a calculator. 4 over root 3 plus 1 and negative 4 over root 3 plus 1. That's just going to make it easier on you to type those into a calculator. So if I do that, again, that's going to give me an imaginary number, so we're not going to worry about that. So please don't stress about imaginary numbers. You're not going to see that when you go to your weekly check-in or anything like that. But that is the process to come up with those answers. 36. X squared plus 6x equals 59. It looks like they already kind of did step 1 for you. It looks like your A value is 1. They went ahead and moved that C value over to the other side. So I can come up with that perfect square number that's going to help me. So it's going to be 6 divided by 2 squared. 6 divided by 2 is 3. 3 squared is 9. So it's going to be x squared plus 6x plus 9 equals 59 plus 9. So when I factor the left-hand side, again, this C value is a 9, so the square root of 9 is 3. So I could do x, 3, and then two numbers that are going to multiply to positive and add to positive. Well, it has to be a positive. If that doesn't make sense going that shortcut route, just do this. A times C goes at the top. B goes down below. Two numbers that multiply to positive 9, but they add to positive 6 are going to be positive 3 and positive 3. So you know that that number is a positive 3. On the right, that's going to be 68. So here's the part where I would take the square root of both sides. The square root and the square cancel each other out. I'm left with x plus 3. Square root of 68, that can be simplified, but we're going to leave it as the square root of 68. 68 is not a perfect square, but I can take out a perfect square and I'll have some left over, but just let's leave that as square root of 68 for right now. Remember, when I take the square root of a number, it's always the positive and negative version. So I'm going to have x plus 3 equals root 68. I'll have x plus 3 equals negative root 68. So if I solve, and then subtract 3 again from the other equation, this is the point where I would type it in my calculator and kind of let the calculator do the work for me. At this level, I'm fine with you leaving it like this. If you want to type that into a calculator and write a decimal, you're more than welcome to. Just again, be comfortable with the steps to get down to that answer. So that was 36. Handful more to go, 38. 5x squared minus 25 equals 10x. They're kind of messing with you now. They're wanting to make sure that you understand what needs to go where. The thing is, I need my a and b term on one side, and I need this constant on the other. So I'm going to have to do a little bit of math to get this thing fixed. So I'll add 25 to both sides. And then because I have my b term on the right, I'll go ahead and subtract that from both sides. Now I'm set up and ready to go. So if I factor this, again, I can't factor it with that a value being a 5. So I think all of these are divisible by 5. So I'm going to divide the entire equation by 5. 5 divided by 5 is 1. Negative 10 divided by 5 is negative 2. 25 divided by 5 is 5. And it kind of made it a little bit more simple. Let's go ahead and come up with that perfect square. So it's going to be b divided by 2 squared, which is going to be positive 1. So I have x squared minus 2x plus 1 equals 5. If I was going too fast for you there, just kind of rewind it and watch it again for a second. Now I'll factor this. So set myself up at the cross. A times c go up top. B goes down below. Two numbers that multiply to 1 but add to negative 2. And don't forget, I always have to go back and divide by a, but in this case, a is 1. So when I divide by 1, it's not going to change those two numbers. So I factored that quadratic. They're both negative 1, so I'm just going to write this as x minus 1 squared equals 5. Here's the part where I'm going to go ahead and take the square root of both sides. The square root and the square cancel each other out. I'm left with x minus 1. Square root of 5 is kind of a nasty decimal, so we're going to leave that as square root of 5, but I'm going to take the positive and negative versions of it. And now it's kind of wash, rinse, repeat, same steps. So I'll take x minus 1, set it equal to root 5. I'll take x minus 1 and set it equal to negative root 5. Go ahead and simplify this. If you want to type that in a calculator, you can. Root 5 plus 1. I don't know. What is that going to be? 2 point something plus 1. So 3 point something, I'm guessing. And then this is going to be negative 2 point something plus 1. So negative 1 point something. Keeping it like this is totally fine. Being able to convert it and type that into a calculator, that's acceptable as well. It's totally up to you. And I think I just caught my mistake. You probably were screaming at me back here. Here I just added 1 to the left side, but what did I forget to do? Right? I added 1 to one side, so I have to add 1 to the other side. So it's super easy to forget, especially when you get comfortable with these steps, to kind of keep moving through these. So slow yourself down, always end that. Make sure you look back through your steps that you've got everything. So now it's going to take me a second to go back through and fix this. 5 plus 1 is 6. So that's the positive and negative square root of 6. All right, there we go. Now everything's fixed. So So square root of 6 plus 1 and negative square root of 6 plus 1. Okay, and then we'll do 40. All right. Again, I can't complete the square if that leading coefficient is not a 1. So I'm basically going to have to divide this entire thing by -3. And hopefully we don't end up with too many nasty numbers. -3 divided by -3 is +1. -24 divided by -3 is 8. -19 divided by -3 is going to be +19 thirds. And then 0 divided by anything is always 0. You can go ahead and switch this over to a decimal. What would that be? 6.3 repeating. But again, we have another situation like we had before. 6.3 repeating. You got to keep track of that repeating value. If you lose it, then technically it's not exact. So I'm going to stick with 19 thirds in this case. So I'll subtract 19 thirds from both sides. X squared plus 8x equals -19 thirds. I'll calculate that, complete the square number. So that's going to be my b value divided by 2 squared. 8 divided by 2 is 4. 4 squared is 16. So that's my magic number that I have to not only add to the left side, but I have to add it to the right. This time I didn't forget. Simplify the right. What is that going to be? 48. -19 thirds plus 16 is going to be 29. 29 thirds. Do that by hand, type into a calculator, it's up to you. And then on the left side, x squared plus 8x plus 16, a times c at the top, b down below. Two numbers that multiply to 16 but add to 8 are going to be 4 and 4. So it's a +4 and a +4, so it's going to be x plus 4 squared. So here's the point where we're going to go ahead and take the square root of both sides. The square root and the square kind of cancel each other out. They undo each other. So I'll have x plus 4 squared into 29 thirds. Again, I can think about that as the square root of 29 over the square root of 3. Either way you think about it, nothing can be simplified, nothing can be reduced. So I'm just going to keep that as positive and negative square root of 29 thirds. So here's the point where we're going to split it up. X plus 4 equals square root of 29 thirds. X plus 4 equals negative square root of 29 thirds. And then to solve for x, I'll subtract 4 from both sides. And I get x equals square root of 29 thirds minus 4. And x equals negative square root of 29 thirds minus 4. Again, that looks nasty. It looks like it's super confusing, but if you just type that in the calculator, it's just a number. It's just a decimal. All right. 42. What's the length and width of the skate park? So this is very similar to example 4 on page 105, where you have those two formulas, the formula for perimeter, the formula for area. You need to rewrite the formula for perimeter in terms of length or width. This example, they rewrote it in terms of width. They solved for W. They could have solved for L as well. They just picked W. It doesn't matter. One way is not really easier than the other. So if you look at 42, they're telling you that the total perimeter is 141.4 feet. And then the area that they want on the inside of this skate park is going to be 1,029.1 square feet. Okay. So again, very similar to the example we saw just a minute ago. I'm going to say that the formula for perimeter is 2 times the length plus 2 times the width is going to be equal to 141.4. And then the formula for area is going to be length times width. What did they solve for back here? They solved for W. So let's go ahead and solve for L, just to show that you can solve for either one. So we're going to go ahead and solve this equation for L. So I'll subtract 2W from both sides. Divide everything by 2. So I have L equals, oh man, what is that going to be? 141.4, 70.7. Okay, so we took that perimeter formula for length or width. We solved for length and said that length equals 70.7 minus W. And now all we're going to do is kind of plug that over here into the area formula. They told us that the area has to be 1,029.1 feet. So 1,029.1 equals length times width. Well, we solved for length. Length is that. So we're going to replace length with what length equals. 70.7 minus W times width. Again, the big thing that we talked about a few minutes ago, or back in that example problem, was that now we have one equation with only one variable, changed from L and W to just W's. So I can solve this, just distribute W. So it's going to be 1,029.1 equals 70.7 W minus W squared. I hate how equations are set up like this, so I'm going to rearrange this a little bit. I'm going to go ahead and flip my two sides so my variables are on the left and my numbers on the right. So all of this information is going to come over to the left. And then all the stuff on the left is going to go to the right. And then I'm going to put it in standard form. I'm going to move this W squared up front. So that'll stay a negative W squared. That'll stay a positive 70.7 W. That's just my comfort. I like to have it like that. I can't factor this if that leading coefficient's negative. So what I'm going to do is I'm going to divide that entire equation by -1. So -1 divided by -1 is +1. 70.7 W divided by -1 is -70.7 W. 1,029.1 divided by -1 is -1,029.1. Essentially what I'm doing is just flipping all my signs. So everything that was negative became positive. Everything that was positive became negative. Okay. So here is the part where we are going to go ahead and complete the square. So I'm going to take that B value, divide it by 2, and square it. $70.7 divided by 2, 35.35. So if I do 35.35 times 35.35, I get W squared minus 70.7 W, 1,000, give me a second, gotta put it in there. All right, I found my whiteout. I wrote a 7, but I want a 2 there. Okay, so when I did this math, negative 70.7 divided by 2, and I squared that, I got the number 1,249.6225. But again, I can't just add that number to the left. I have to add it to the right as well. So since I'm running out of room here, I'm going to go ahead and just type this on my calculator. I added this, take this number, and then I'm going to subtract 1,029.1. And I get 220.5225. All right, so how I came up with that number is I already had negative 1,029.1 on the right. So I added that to the left. I also added it to the right, but because I was running out of the room, or because I was running out of room, I went ahead and just added that on my calculator, and I got 220.5225. Don't get discouraged with all these decimals. Just keep plugging through it. Stick with the steps, right? Use a calculator. You'll get through it. Okay, so this is the part where I will just take essentially the square root of that C value to complete that perfect square. So just go ahead and type that into your calculator. And when I do that, I get W squared minus 70.7W, and then the square root of that is 35.35. So it's going to be W 35.35 squared equals 220.5225. Remember, just setting this up, you could come over here and do slide divide bottoms up, but coming up with two numbers that multiply to this and add to this might be a little bit nasty, right? Because the numbers are not only big, but there's decimals. Remember, the shortcut to this is a perfect square. So to come up with this number, all you have to do is just take the square root of that number right there, okay? So that's 35.35. Now you just have to decide, is it positive or negative? Well, if these two numbers have to add to negative 70.7, they have to be negative, right? They multiply to this, and then the same two numbers add to this. So since they have to add to a negative, that means the number has to be negative. So here's the point where I can take the square root of both sides. The square root and the square undo each other. So I'm left with W minus 35.35. The square root of 220.5225, I'm sure is not a nice number. Let me check it out. It is 14.85. So not super bad. It's not that bad. And now is when I'm gonna kind of set the two equations up. Remember, the square root of a number gives you the positive and negative version. So I'm gonna take W minus 35.35 and set it equal to positive 14.85. I'll also take W minus 35.35 and set it equal to the negative version of that number. So if I do some math, add 35.35 to both sides, I'm going to end up with W equals 49. That's too much. 40.2, I think. Let me check it out. $50.2. And then over here, it's going to be 35.35 minus 14.8, 20.5. All right. So there are our two values of W. All right. And then length and width are 50.2 and 20.5. Let's go ahead and look at 44. Write the equation in vertex form, identify the maximum and minimum value of the graph. It's the equation. So let's take a look at 44. Almost done. Y equals x squared minus 14x plus 71. So the first thing we want to do is factor this. If we factor it, then we can graph it, and we can identify information from it. If you try to factor this the way it sits, essentially what you're going to do is come over here. A times C goes to the top, B goes down below, and you're not going to be able to come up with any numbers to make that work. So you have to complete the square. So if I complete the square, what I'm going to do is subtract that constant from both sides. Now I will do that formula to kind of come up with that magic number, right? To complete that square on the left and on the right side. So I take my B value, divide it by 2, and square it. Negative 14 divided by 2 is negative 7. Negative 7 squared is 49. So that magic number is going to be 49 that I need on both sides. When I When I factor the right-hand side, again, now you can set yourself up with the cross if you're more comfortable with that. A times C goes at the top. B goes down at the bottom. Two numbers that multiply to 49 but add to negative 14 are 7 and 7. But wait a second, as soon as I said that, I realized that when I add those two, that adds to positive 14. I need them to add to negative 14. So I think I want to throw some negatives on there. Just like I just showed you, and I picked those two numbers, what I did mentally in my head when I was writing those down is I verified it. Does 7 and 7 multiply to 49? Yep. Does 7 and 7 add to negative 14? No. So make sure you're checking yourself when you're coming up with those numbers. So on the left, I have 49 minus 71 is negative 22. And then on the right, they're both negative 7, so it's going to be x minus 7 squared. Now, this is the point where I can go ahead and add 22 to move that constant back over to the right-hand side. So what I've essentially done is taken that standard form that we started off with, and I rewrote this in vertex form. So let's look and see what they want us to do. Write the equation in vertex form, which I did. Identify the maximum or minimum value of the graph. When they're talking about maximum or minimums, this is what they're talking about. If I have a parabola that looks something like this, this parabola has a minimum y value. That minimum y value is that vertex where it bottoms out. That's my minimum. And then it has a maximum if it looks something like that. This has a maximum y value right there. It's that vertex right there. That's my maximum. So when they're referring to minimums and maximum, they're referring to y values. What's the minimum y value that this function ever touches? What's the maximum y value that this function ever touches? And again, you could figure this out by just finding the vertex, right? Since this is in vertex form, I know my vertex is going to be the opposite of that number right there. So the opposite of negative 7, which is positive 7. And then the h value, or I'm sorry, the k value is going to be 22. So if this is h, this is k. Just remember, you always have to take the opposite of that number on the inside. So if I were to graph this parabola, it would be a positive parabola, so it would look something like this, and then the vertex, that bottom point right there, would be at 7, 22. So it would look something like that right there. So the question, what's the minimum or maximum value? It looks like this would have a minimum because it's a positive parabola. And then this y value right here has a y value of 22. So it would have a minimum at y equals 22. All right, 46. Got 2 more to go. Y equals negative 3x squared plus 36x minus 93. Kind of getting to some bigger numbers, just, trust in that process that I showed back at the beginning. In this case, I can't factor this. I can't complete the square until that a value is a positive 1. So what I essentially want to do is take a GCF, in this case of negative 3. So it's going to be y equals, we'll GCF out that negative 3. So negative 3x squared divided by negative 3 leaves me with 1. 36x divided by negative 3, that's going to be negative 12x. And then negative 93 divided by negative 3 is positive 31. So that worked out nice. No nasty fractions or decimals. So here's the point where I can go ahead and complete the square. I think I'm actually going to back up one step now that I did that. Let's do this. Give me a second. And I'll explain why here in just a second. I don't know if you remember or not, but in that example that we did a little while ago where I moved that number over to the left side of the equation and then I added that perfect square on the inside, but I didn't multiply it by the GCF, that can get a little bit messy. So I think what I actually want to do first here is I'm going to go ahead and add 93 to both sides. So I get y plus 93 equals negative 3x squared plus 36x. Here's the point where I'm going to go ahead and GCF out that negative 3. So y plus 93 equals, take out the GCF of negative 3. Now we're not having to switch things back and forth between inside the parentheses versus outside the parentheses. We'll just move it before we get started, and that way it's a little bit simpler. So do my formula, b divided by 2 squared. My b value is negative 12, so negative 12 divided by 2 is negative 6. Negative 6 squared is 36. So that's going to be my magic number that I'm adding to the inside of the parentheses. 36. But remember, like the example problem I did a little while ago, when I'm adding 36 on the right-hand side, I'm technically not adding 36 because I'm going to have to distribute this negative 3. So negative 3 times 36, that's, what is that? Negative 9108. So that's negative 108. So technically what I'm adding is negative 108. So I'm going to do the same thing to the left-hand side. Y plus 93 minus 108. Because I'm not just adding 36. If I redistribute that negative 3, I'm technically adding negative 108. So I need to add negative 108 to the left side as well. Here's the part where we can complete the square. Let's clean up the left side. 93 minus 108 is going to be 7, 10, 15, negative 15. Negative 3 still on the outside. And then on the inside, if I factor this, so a times c goes at the top, b goes at the bottom. Two numbers that multiply to 36 but add to negative 12 are negative 6 and negative 6. So it's going to be x minus 6 squared. So to kind of set this up in factored or in vertex form, I'm going to go ahead and add 15 to both sides. So I'll have y equals negative 3 x minus 6 squared plus 15. And if we were to graph this, this original parabola, that's a negative parabola. So it would look something like this, like an upside down kind of frowny face. But specifically, we can get that a little more accurate by knowing that it's going to be reflected, which again, we know that. It's going to be stretched by a factor of 3, so it's going to kind of be a little bit skinnier than normal parabolas. The vertex is going to be at the opposite of this number. So h is going to be positive 6 and k is going to be 15. So if I were to actually sketch this graph a little bit better, 6 comma 15, maybe something like that. So any negative parabola is always going to have a maximum because it reaches a maximum height, and that height is 15. So this has a max at y equals 15. All right, one more. I'm glad we skipped the odds because this would have been a really long video. It's already super long. So 48. Y equals 0.5 x squared plus 0.5 x plus 2.125. They got to end on a difficult note, right? To be honest, oh man, I think I'm just going to go ahead and try to take out a GCF. I was thinking about something else, but let's stick with that. I think that might actually work. So in this case, my A value is 0.5. So what I'm going to do is I'm going to GCF. I'm going to take out a 0.5 from everybody. I think my first step is I'm going to get rid of this constant, 2.125. Okay. So now I'll have, kind of like I did in that last example, I'll have y minus 2.125 equals 0.5 x squared plus 0.5x. So now 0.5 will definitely work. Y minus 2.125 equals, take the GCF of 0.5, divide everything by 0.5. I'll end up with x squared plus x. I'll come up with that perfect square number that I'm needing. My b value is 1. So it's going to be 1 divided by 2 squared. 1/2 squared is the same thing. You can type that in your calculator, but it's the same thing as 1/4. So 1/4 is kind of that magic number, or 0.25, whatever you want to deal with. Since this already has decimals, let's stick with decimals. So I have y minus 2.125, and then I have 0.5 x squared plus x plus 0.25. Now keep in mind, I am not just adding 0.25 on the right-hand side. If I distribute this 0.5, I'm actually adding 0.125. So when I distribute that, this number that I'm adding in there is actually 0.125. So that's what I'm going to add on the left side as well. Not just 0.25, I'm adding 0.125. Because again, if I distribute that, bam, bam, 0.25 times 0.5, when I multiply those together, it's actually 0.125. So I have to add that to the left. Clean this up a little bit. Y minus 2.125 plus 0.125. That's going to be y minus 2 equals. I'll still have that a value on the outside. When I factor this, like I said before, you could come over here and you could draw yourself an x, and you can go through that process. But once you start getting decimals and things like that, it becomes a little bit more difficult. So I think I'm just going to stick with just taking the square root of that number right there. So the square root of 0.25 is going to be 1/2. So I'm going to have x plus 1/2, x plus 0.5, however you want to write it, squared. Now's the point where I'm going to go ahead and move that constant over to the other side. So I'll add 2 to both sides. Y equals 0.5, x plus 0.5 squared plus 2. These problems get way more difficult, at least mentally. They look more challenging when they have decimals and fractions, but just trust in the process. Make sure you're sticking with the process. Just move that constant over to the left, take out that GCF, make sure your a value is 1, complete the square, right? Simplify it, move that constant back over to the right-hand side, and now you have a vertex form of that original quadratic. So this is a positive quadratic. So when I go to graph it, it's going to look something like that, like a happy face. But specifically, my vertex is going to be at negative 0.5, comma 2. So if I were to graph this, negative 0.5, comma 2, looks something like that. Again, this is going to have a minimum because it only goes down so far. When they're talking about minimums and maximums, it's y values. How far does it have a minimum y value, a maximum y value? So this one has a minimum. It only goes down to y equals 2. So this has a minimum at y equals 2.